Well, hi, and welcome to my shop, and thank you for joining me today. It's August 3rd, 2023, and I'm going to be looking at this array of Citizens Band radio test equipment that's been put together by B&K Precision, a company that makes test equipment among other things. So I've acquired this recently. I didn't go out looking for it. It was basically, I could almost say, dumped on me, all this equipment. And what I'm really talking about are four pieces. That's this, the scope, the signal generator, and the frequency counter. So what I hope to do today is simply prove that everything can work together like this. I've looked at each component separately and to see if there was anything obviously wrong with any particular piece, and there actually wasn't, except for the oscilloscope had an instability which I corrected. So the equipment has shown up, I think, probably working as it's intended to. Now, there's a good chance you're a new viewer here. You've come to my channel to see this stuff about CB radio. Maybe you're a CB person. Just let me clarify who I am, kind of, when it comes to that. Yes, I got a CB license. My call sign is XM435152, but that was many, many years ago when I was doing the CB thing, during the original CB period, which would be from the late 50s or early 60s, believe it or not. Its popular phase through the 1970s, and then it's quiet down and eventual death, basically, through the 80s, as I understand it. Now, I'm not a CB connoisseur, so I may have the story a little bit wrong. Here in Canada, we're not allowed to use a CB radio in your car anymore, as of almost 10 years ago now, I think. So that pretty much ended CB radio here in Canada, as far as I know. Now, there is a CB club in Ontario. It's the province I'm in. But I don't know anything about it, at least not yet. So, now, another thing too is, while this is test equipment, it in itself doesn't fix anything for anybody. It's really, all this equipment is used to provide signals and observe results, and then the technician would have to make decisions about what might be wrong or require attention. So basically, this equipment can help you check out the operation of the CB radio and find out if there's anything out of sorts. Everything from output power to modulation percentage to frequency accuracy, and perhaps some more stuff in here. There's also a way to judge distortion in the audio circuits and the audio output of the radio. So how much of this I can make work? Gee, I don't know. That's why I have it here all set up now. As I mentioned, you may not have watched them. I went through every component, but putting them all together raises some interesting questions. So one of them is on the back of this. There are three inputs or outputs. Well, I can't really tip it up, so I'll just bring the camera over. There you see them there. Three different connections. One going to each piece of equipment: the signal generator, the frequency counter, and the scope. So this is kind of your central base piece of equipment, I guess you could call it, or control panel, maybe you can call it that too. So this, what I'm tightening right now, is the output from the radio under test. This is the radio under test. This one's just sitting here. This radio is switched on. It's being powered from a power supply over yonder. And from some simple testing done earlier, it appears to work. Now, why exactly you have an oscilloscope connected to all this, I'm not even sure, to be honest with you. And the other thing is, you have a signal generator here that's connected into here. You could assume that the idea is the signal generator signal is passed through here, comes out into the antenna of the radio, so you can hear the signal generator. Now, one big problem with that is, what happens if you transmit with the radio? Won't the transmission go the other way with a fair bit of power and go right backwards into here? So I believe there's a relay in here which will detect the output of the radio if you push the talk button over here, and the relay will operate, and that will block any of the radio's output signal from getting back into the signal generator and blowing this guy up. I think that's how it works. Since I'm not absolutely sure, I'm going to disconnect this right now, because it could be relatively unforgiving if you make this mistake. Now, in a little bit of instructions I have read, I have not read much instructions with this, it does talk about this feature, that sooner or later a technician will accidentally transmit when, unintentionally, and so some protection is required, and there's some relay in here, which maybe we're going to hear it. I think I've heard it before, snapping in and out. Didn't seem to me to be very responsive, though, so you would almost think, well, if you transmit... The reason I'm dwelling on this is because this piece of equipment is potentially at risk. If you hit the transmit button, and that relay takes some time to detect the situation and operate, during that time the output is going into this guy. So we have to assume everything's been made, with this kind of operation or fault in mind. So we're going to experiment with that a little bit right off the bat. Today, all I really hope to do is just see that all this stuff works together. After that, I may attempt to actually fool around with the internals in this radio here, this older radio. This one here is really quite new. There's nothing wrong with it, I'm sure, and there's no way I'm going to do anything inside a radio like that to fix it or improve it or anything. But I think you'll see that the output of this radio is low. So, maybe there's something that can be done. I don't know. So, but for today, it's all about the test equipment. So why don't we start with transmitting from here and seeing if that relay operates. Pretty straightforward. Now, what about the rest of the equipment? So this frequency counter should count the frequency coming out of here. We should see it come up here. 27 megahertz plus. A little bit above 27 megahertz. The power coming out of here there's no adjustment for it. It is what it is. I believe these radios are limited to 4 watts, but I could be wrong about that. Could be less. From the measurements I've done, this radio kicks out about a little over 3 watts, but I'm very doubtful about all these measurements. In the meantime, I have more CB radios. I have one in particular set up all the time with a 102-inch whip on it, which I use for receiving. I don't try to talk to anybody. Who would I talk to? I don't know. Well, there is one fellow, a friend of mine named Les, who is about, I'm going to say, 7 kilometers from here on the other side of hills. So there's one possible person I might be able to talk to, but not from in here. I have no CB antenna available in here of any sort. So talking about that for a minute, this device has a fake antenna, just a resistor inside it, and when this switch is switched the way it is, not this way, but this way, then this thing's output goes into that resistor. So if I do throw it this way, then I have another terminal here. I could put an antenna on this if I had one, and I would if I had one. But we'll have to think about that a little more too. So this is going to be internal, and the meter here can read a number of things. And I'm going to have to change the lighting in here because I've got an overhead light that's just too bright. There, that's a little easier for you to... There we go, now we can see that. So it's very dark in here now for me, but the camera has adjusted itself, so it's not so dark for you. So you can see it's got a meter here. It says SWR, and it also says watts up here. So it measures different things depending upon how this selector is set. This can be set for forward power, reverse power. That's power bouncing back from the antenna. If electricity can bounce. This is a set position, and you're setting the meter to its set point in order you can read the standing wave ratio on your set. Of course, there'd be no real SWR measurement unless you have an antenna. At least that's what I would think. What SWR could there be if you're feeding into just a resistive load of the proper impedance? I don't know. Okay, so we have the output disconnected from here, so we're safe. Let's transmit a little bit and see what happens. We're set on forward power. Okay, let's just go up a little bit. Yeah, just back a little bit, because you want to be able to see this frequency counter. There we are, 277042. What's going on over here? Now, this has an interesting feature. Since back in the day, having an oscilloscope that would go up to, say, 30 megahertz, which you would require if you want to look at the actual signal coming right out of the back of one of these radios. Having a scope like that, that's an expensive investment for a small repair shop. You're much more likely to have a 5 megahertz scope. So with that in mind, this piece of equipment converts the output of the transmitter from 27 megahertz down into 1 megahertz. And that's what's being sent over to the scope. So that's another function of this device. What is it you're going to see over here? I guess it would be the envelope shape of the transmission. Why don't we just see what happens there? Now, I don't even know that this microphone is microphoning. All I know is if I push this button, it switches to transmit. This microphone did not come with this radio. I just stuck it. Let's find out. So the way to do this, I can literally just tap the microphone and watch this, and we'll see if there's any response. Okay. There's no response. Okay, another way. What would be another way? Tain't no other way. So I have the feeling the microphone is not actually connecting in here. That's a bit of a problem. That's definitely a problem. And I'm not sure how I can overcome it. Let's just try this again. So there is a %. So if I hook the audio from here, where's the audio, by the way? We hear nothing from this radio. So I'm watching this meter go here. It's set to, it says SRF, signal RF. Can we get anything here about modulation? I don't see it. Yeah, I'm pretty sure I don't have a microphone working here. Well, we can just switch to this other radio, which will certainly produce modulation. But let's not do that just yet. Well, maybe we actually have to. So another feature of this guy is it has a built-in audio generator right here. It has a speaker. We'll put this onto single tone. That sound you hear is coming out of here. And the idea is, you hold the microphone. Now, you wouldn't normally have this kind of desk microphone. You would hold the microphone like that and go like this. It has a couple different tone settings. This has an audio input over here, which we'll make use of at some point. So you can take the audio out of the radio and feed it into this part of this device, which you can then measure a few things: power output and also distortion, supposedly. I suppose that's when you utilize this guy. Can we do any more with this radio without a good microphone on it? Without a talkable microphone? I don't think so. So I'm going to stop the video for a minute and try to find another microphone that'll actually drive this properly. And hopefully I can find it. Somewhere is the real microphone. I just lost it somewhere. I must find it. Okay, I've got a few microphones here. How did I end up with all this stuff? So here's one, Cobra. This is a Cobra. And it's got a little, it's going to show you what channel there. And look at this plug. There's just full of contacts. Well, this is a 4 contact plug. So this is not going to work, even though it's a Cobra. Let's see what else I've got here. I've got this one here, a Yaesu. What are the chances? Probably not very good, but let's give it a try. Now some of these, I've done this already. As soon as you plug them in, the radio tries to transmit or something like that. So it's a good chance this won't even go in at all. Go in this way. I don't know. Okay, so far. The other thing is the audio is often dependent on how this is plugged in. Ooh, what happened there? Well, it'll transmit, but I don't think there's any audio coming through. Or are we discovering this radio doesn't work? I know this radio works. It worked. Okay, so this guy didn't work out. What happened? So I'm shorting it out even if I do this. There we go. Set this one aside. And let's try another one. It's a Cobra. Hey, Cobra. Oh, this looks very hopeful. More pins. VE3. Whoop, that's my hand call. Yeah, I'm not supposed to do that. There's a dynamite control here. Ooh, that was turned down. What's going on here? What's going on with this? Howa. Okay, well, let's use the speaker thing so I don't have to sound like a goof. Okay, so stuff on the scope here. Well, what's happening with this? The output is dropping too low for this guy to continue to track it. As soon as you start transmitting. Or the transmitted wave shape is somehow not working well with this device. Got a microphone though. Now, let's take a look at a few more things. I'm just going to change the lights again so you can read the meter. And we'll still look for the proper microphone at some point. Down on the lights. How much power is coming out of this guy? Oh good, there's the audio too. Of course, it doesn't really have an antenna hooked up. A little dirt in the volume control. So that's why it's kind of quiet. Okay, watching the power. We're on the 0 to 10 scale. So that's 1 watt, 2 watts, 3 watts. So straight up is kind of what you would expect out of this. And what we're getting on the watt scale here is less than 1 watt of output. Well, that seems kind of disappointing. Now I'm hooked up to a powerful power supply. There's no way there's a drop on the supply voltage to the radio just because I'm transmitting with it. This is XM43 5152. Anybody hear me? Hello. No man, if somebody came back I'd pack it in for the day. Okay, well let's compare. We'll flip to this other radio because it's quite easy to do. Now this one is not on a really good power supply. It's on a crummy power supply. Okay, we better turn this one off. And then we're going to move the transmitter cable from one radio to the other here. Oh boy, it's stuck in there. So the cool weather has left us. Here it's going to be a warm day, but not hot by the standards many people are facing. But for here, it's going to be fairly warm, about 27 today. Okay, I'm going to lift this up so we can hear the speaker a little better. channel 38, that seems a little high. Let's go down to the trucker channel. Okay, so this is now connected to here. So I'm going to transmit with it. Watch the power now. Whoops. So see, we're just over 2 watts on here. Hear the relay? A little slow, eh? So the last radio didn't tip that relay. I didn't notice it. Maybe it did. The oscilloscope's doing some interesting stuff. Let's just take a look at it. Okay, so we'll see if we can sync this guy up here. Turn off either this way or that way. So I had it up on a TV setting. That's not so good. Let's put it here. There we are. It's just a funny coincidence. I'm going to go a little bit bigger. Not the best triggering on here. But there we are. But that's the actual 27 megahertz signal. So if I talk into it, well, let's put the tone into it. Slow this guy way down, like this. Let me try the same thing. Slow him down a little more. Oops, wrong control. What was that? This is slow him down. Vertical, horizontal. So when you're looking at this with a camera, of course, there's an additional effect of the camera itself in here. So I can only slow it down with this control. This is the slowest setting unless I go down the line, which is kind of crazy. I'm not sure that's a good idea. I guess there's no adjustment when you put it to line. Go back here. How would you interpret that? You are seeing it fairly good, except you're seeing something going across like this that doesn't actually exist for my eyes. We have a different tone here, double tone. I'm not sure what you're getting out of this. If you want to see the envelope, so you want to see this happening at the audio frequency, and then the inside should just be kind of white with the RF, if I can put it that way. Maybe I got this too slow. Oh, that's what we're looking for right there. That is it. So we've got, I think, almost 100%. It's messy, but right in here is a flat area. very messy. Let's go back to the single tone. Now, you know what? There is a... oh, it looks stable. Looks more stable to you on the camera. Now, what about this dynamic thing up here? Oh, that's the other radio. That's not this one. Never mind that. Okay. Next step would be take some audio out of this radio that we're playing with and feed it around into this audio circuit and see what we can get. See what kind of displays we get and what it looks like on the equipment. But you know what? It's coffee break time here. Now, I just came from outside my house and wow, it's hot. Hot for here. 27 is a hot day here. But the humidity is very high. That often happens in this area. Very high humidity. Maybe not like Florida, but still. Okay, so what I've done is I've taken the audio output out of here. It's on this cable now. Fed it into the front of the of this guy here where the audio goes in. So we should be able to do some audio stuff. The first one is there's a button here. Have it like that. You get that tone from the tone generator in here. But if you flip it over, you're hearing the radio and the hum. So the hum is probably from the lousy power supply I have powering this right now. That's probably where the hum's coming from. Okay, so what do we do now? So now we can do some measurements of the audio output here. And let's just try a few things. See what happens. So first of all, there's a selector here that selects what output resistance you want to feed into. So let me just turn the radio down. Turn it down here. 16 ohms, 8 ohms, 4 ohms. I don't know offhand, but I wouldn't be surprised if it's 4 ohms. I have it set to 8 right now. And the meter here, if we come this way, and these three settings are for watts. First setting is 0.1, so it would be 0.1 watts full scale. I believe that's what we'd be looking at. And this is watts of audio. This is not watts of power. No, it's definitely not watts of power. We'll play on the words there. So what we're going to do now is we're going to set this to the tone. And let's just let it have it here. Holy smokes! What was all that? Come on, really? Do I have the volume up high over here? Let me turn the volume down on the radio. This should not go anywhere. It's still going. Some kind of hum or some kind of something, some kind of... It can't be a ground loop. I've plugged all the equipment into the same power bar. Well, what's happening here? Let's put it on 10. 10 watts. Really? I got the volume turned down to nothing here. Okay, I've turned off the radio. The radio's no longer on. Well, okay, that's good. that kind of worked. Turn it on. Well, wait, what about the hiss? If I just turn up the hiss. There we are. Let's go down here. Okay, so we're just listening to the radio hiss. Actually, we could hear it if I did this. Yeah. Just recently, my wife has become fascinated with white noise, pink noise, and brown noise. I told her I'd never heard of brown noise. Not quite sure she realizes what it is, but she's using it to help with her sleep. So, okay. So this is telling me that into 8 ohms, this guy is putting out roughly 5 watts right now. Really? 5 watts? I mean, normally that would be hugely loud. Look over here. The scope is showing the noise here. So how did this get switched from RF to AF? Is that what happened here? Good question. So let me turn down the radio. Actually, the radio was up full, so I turn it down. Yeah. That sure looks like the noise. What's happening here? Okay, next thing we can do now. We're going to avoid transmitting with the transmitter. I'm going to connect the signal generator. We haven't even used this yet. Yeah, I think maybe this is the missing component here. Of course this is the missing component. If I squeeze this microphone, I'm not going to have any audio come out. Dummy. I'm a dummy. That's not the way to do this. Okay, we'll put the microphone there. Now, first we want to hear the radio. Lovely. We're on channel 10 here. And I want to flip this onto channel 10. It's on 40 right now, so we'll go to 10. You can see this dial's been left for a long time in this position and it turned brown. 10 is... that's 10. No, we don't want that on. We want this turned up a bit. That's our problem. There we are. That's the signal generator. Now there's a delta tune here. Didn't seem to do a thing. Could be a signal strength meter here. SRF. Signal RF. The meter's sitting at the bottom. So let's crank it up here. This is not the radio, Jim. This is the radio. Oh, okay. There's no meters, nothing fancy on this one. So we don't really know. We just listen to the quieting. So if you listen to the background hiss. Not really going away. There's the background hiss. Don't know for sure where that hiss would be coming from. It seems to be coming from the radio. Okay, now we can do this audio thing. So I turn down this volume because we don't need to listen to it. We have this set to 1 watt. And so we'd be reading it. Oh, no. I've got to. Yeah. 1 watt, that's it right there. Yes, there it is. Okay, so say how many watts output can we get? So this would be on the 1 watt scale, this would be 1/10 of a watt right now, which is probably plenty loud if I let it come out of the speaker here. Now, so at 1 watt, now we can try this percent distortion thing down here. Percent distortion. So with 1 watt going, we'll flip it to set full scale. Here we are. Set full scale. I can't do it. Need more volume? Need more volume? Yeah. Full scale, really? Wow. Okay, so that's full scale there. That's full up on the setting. So the volume is stupidly high at this point, I think. Let's just set it carefully so it's right on the set point. Now we flip to adjust for minimum. Adjust for minimum. Now this didn't work last time I did this. It's not working this time either. I'm expecting the meter to drop. No drop happening. Why could that be? Something wrong with the machine. Set full scale. Let's set it half scale. Half scale. Whack right over. Can we get it to come down at all? Volume down. Okay. Set full scale. We can get half scale with this on full. Adjust for minimum. No, we can't do it. So either I'm doing something wrong here, which is quite likely, or this feature is not working properly, which kind of
disappointing in a way. Because this is something you don't normally encounter. You usually get special equipment to do the percent distortion measurements. I assume this is a harmonic distortion. Well, not sure what to try here with this. What if I jack up the input signal level here from here? Just step back a wee bit. Bigger view of things. Suppose I just what was I going to do? Crank up the input to the radio and see if that doesn't. It's hardly making a difference here because there's probably an automatic volume control circuit in the radio. Okay, so that's much higher now. RF level. So we're kicking out a pretty strong signal. I can change the. Oh, I wonder if maybe having the audio on was a mistake. No, how can that be a mistake? This is all about the audio here. Maybe a wrong frequency picked. Maybe a wrong amplitude. Let's check this. So we're in percent modulation, and the meter is showing almost 30%. You can hear it. This is interesting. Watch my scope and listen. Watch and listen. Train your ear. Okay, stop the shaky stuff, please. Stop the shaky stuff. So the wobbling here is probably the 60 cycle hum that's coming through. And now I'm going to turn up the audio until we get distortion. The input until we see distortion. Yeah, input. How did I do that again? I did it over here. Amplitude modulation. Yes, sir. Okay, listening now. Ooh. Watch what happens at the peak of this signal. Hear that buzzing sound? Can you see that it's squaring off here? It's changing shape. A sudden angle. The point here has become very sharp at the top. You get sharp points on here when you have harmonics, higher frequency harmonics. This should be here. So we discovered a level of distortion that can happen, but it's really because the signal generator here is driving the. That's 50% on this meter. So you should be good to 50%, I would think. Here's 30%, we're good. But any higher, you can hear it. Okay, we'll set it just below 30%. So that was useful. Although I can hear it. You don't really need to see it. When you can hear it, you know what you're hearing. Percent. Full scale. Null. No. What happened there? This control's dirty. Set to the lowest point. Okay, we're getting somewhere now. Seem to be getting somewhere. So adjust for minimum. And I'm guessing the minimum is the reading. So at this point, according to my set full scale, yep, that's the reading. 20% distortion. Really? So let's back down the modulation. So now we got to reset everything. We'll put it here. Full scale. Can I get there? I can't get there anymore. Okay, so we'll continue this up until we get to full scale. This is the minimum signal necessary to get this to full scale. Adjust for minimum. Minimums. You guys fly airplanes? Anybody fly an airplane? There we are, 20%. Well, really? 20% distortion. Now, If you buy a stereo, they'll tell you the harmonic distortion at high output levels. They'll proudly tell you it's 0.1% or even 0.01%. You can't really hear it until it's up around 3 or 4%. So a lot of vintage radios came right out of the factory with 3 or 4% harmonic distortion in them, but you can't hear it. Your ear just can't pick up on that. More than that, well, I would say it's this kind of stuff we were seeing on the scope. Let's regenerate the scope distortion. What's this meter going to do? Okay, so now we have the distortion showing up here. You can hear it. Okay. Set full scale. Minimum. Okay, so the minimum's gone way higher. It's up getting close to 30% distortion. Now, would this be 30% distortion? Gee, I don't know. I don't know if you can look at this and say that. So it seems to be somehow responding to the amount of distortion. So let's lower this way down. Okay, and we can crank up the volume here. Doesn't sound like that's causing any distortion. Crank up the volume. And now we want to do this set full scale. We probably can't do it. Can't get there. So in order to get there, raise this volume a little higher. Yep, we can get there. Sounds to me like there's distortion starting right in here. Hard to say. There we are. Set for minimum. Minimum. I don't know if this is working right. I better read the instructions. It doesn't say it, but maybe it needs a certain level in some way to make this work. Because now it's telling me it's 30% distortion. Yeah, this thing's jumping all around, but I think that's more along the lines of triggering issues. Not sure what to make of that. Jumping around thing just doesn't do anything. No. Maybe if we speed it up. No, that's not going to help. Slow it down. It's all jumpy. I don't know. Could be this is from the hum in the power supply. I'm not sure. Okay. Interesting stuff. What to make of it all. Let's try a different frequency over here. Over here. So we'll do it at 400 hertz. Well, this definitely looks distorted, even though it's all over the map. Sure looks distorted. All kinds of distortion there. Okay, down on the level from the radio. Distortion seems to remain the whole time. I'm looking at the scope here. Down there, we will now attempt full scale. There's no hope of getting full scale with this level of volume. The modulation over here is way down. Let's put this modulation up. Yeah, I had this way down. Let's put it at, let's say, 20% modulation. That's quite low. Now we're up. Minimum. Minimize. Not minimizing. Full scale. Dirty controls. Minimize. No, I'm not going to do anything. Well, it could be that there are calibration adjustments inside here that need to be adjusted and fixed. Could be this is a crappy machine. I kind of doubt that. I can't imagine they would put this on the market with malarkey in it. What else am I not getting right? Let's turn this down, because we're at 400 now, 400 hertz. Turn this way down. The volume's pretty high on the radio. The modulation go a little higher. Let's go a little lower. Look for. So I would expect this to go right down, because I don't hear any distortion. also the potential that, you know, this amplifier here has its own restrictions and causes distortion. What exactly is this looking at? Is this looking straight at these inputs? Or is there stuff in here and then the signal gets over here, and some of the things we're seeing could be from stuff in here? I think that's possible. Well, I think I've probably done enough for now, because it's getting late in the day, late in the morning rather, and it is nice and sunny outside. Great. So I'm going to just spend some of the rest of my day thinking about this and trying to decide what I should try to do next. I do have the service manual for this guy, and I have the service manual for this guy. So I have the potential to calibrate it internally if it requires it and the like. That's what I'll do. I'll study the manuals for this and this. But then tomorrow I may go inside this and see if there aren't some things that I can adjust and calibrate, and maybe with the signal generator too. Okay, so thanks a lot for watching. It's gotten quite warm in here. Everything got warmed up, so it's gotten fairly warm in my shop. Great. Okay, I'm babbling. Thanks a lot for watching, and tune in again tomorrow to see how this all works out, if it does at all. Have a great day, and see you.